Hello and welcome. This is the fourth video in this Lathe Restoration and Improvements video series. In the last video we got the Reeves Drive working here, and I kind of temporarily made this mechanism here to move this top pulley sheave in and out. It was just so I can show how the mechanism worked. In this video I want to actually close all this area in, and I want to make a control on the front here to move this sheave in and out so that it can be done a lot easier than this mechanism here. The idea is to put a kind of a heavy plate all the way down the front here, and that will give me some area or places I can bolt or weld pieces to for this mechanism to pivot on, and that will make it easier to work out how everything should work. Now I think I'll do this up in CAD first so I can get a good idea of where things should be and how they fit onto the front here. So of course that's our cardboard aided design. So here I am testing out the template, and that works nicely. Now I don't have steel wide enough for this, so I have to make this out of two pieces. This is a larger piece, and then I use a more narrow piece, and these are then welded together, and that gives me the width I need. I'm boring out a hole for the spindle housing. I also bore out a hole for where the pulley shaft comes through. It's mainly just to make it easier for me to cut out, as you'll see. I'm cutting off the two top angles here. And this is the slot for the motor shaft. And then I test fit that onto the machine. And all the belts and everything are inside that area, which is good. Now that plate was going to be mounted hard up against the stand, but I can't do that because of a flange on the spindle housing. So I'm making these little pedestals or standoffs which will step that plate out about 8mm. They're all cut off in the lathe and cleaned up, and they're all finished there. Then I work out where I need to drill the holes for these standoffs. Those are all drilled out to 8mm for M8 bolts. And then I bolt those standoffs onto the plate and weld them all in place. That will make it a lot easier to mount the plate onto the machine. I'm using these ginormous F-clamps that I made to hold everything together. And I drill out those fixing holes, top and bottom. I mentioned in one of my other videos that the end of this lathe stand has a 10mm plate, and that's what I'm tapping out here. The other bolts will just go through the legs. I have the plate bolted on, and that worked out pretty well. It's actually not sitting hard up against the stand like how I initially thought it would be, and that's because there's a flange on this headstock here, and to do that I'd either have to cut a bigger hole in the plate, or I'd have to cut that flange off for it to move in. I think it looks quite good with the flange there, so what I've done is just stepped it out with those pedestals, and we still have plenty of room in here to do what we need with the speed control. So that is the next step, is to work on the speed control. And I had a comment on my last video about a suggestion of making the speed control kind of like a winding handle. So instead of just a lever that goes from left to right, you know, to speed it up, and you only have half a turn type thing, it's more of a handle that you have more control over the speed. So, you know, it might be 5 turns to speed it up and 5 turns to slow it down. And that handle will come out somewhere around about here. There'll be another plate along the front here, and the handle will come out and we'll be able to turn it over there. To do that, the design is going to be similar to what we had with that makeshift fork that I made to show the demonstration in the last video. But basically 2 bits of steel that are bolted on here, and they come out at an angle and they pivot around about where this line is here. So there'll be a bracket here with a bar through it, and it will be able to pivot. So that gives it its movement this way, if that makes sense. Once that is done, we need a way to push the pulley out, and that will be through the handle at the front here. So the idea is we'll have a bit of all thread that travels right through here, and on that piece of all thread will be a piece of steel so long, I'm not really sure yet, but it will be tapered, and on the bits of steel that come down here for the sort of hinged bracket, there will be another piece of steel that's also tapered, and when you wind the handle in, those bits of steel go closer together, and that will push the fork out, which will push this pulley out. It's a little bit hard to explain how that works, but I think it'll be a bit clearer once I start making the parts. I'll start with the pivot bracket, and there's 3 parts to this. This is 25mm by 12mm steel. I square out the ends of the 2 side pieces. This was really close, but I actually got in there, and I was able to drill the 12mm hole that I need. Then that's all clamped up on the bench, and I weld all that into place. I tidy that up on the grinder a little bit later on off camera. Now I'm working on the fork bracket, and this is a piece of 50mm by 5mm plate, and I cut that right down the centre so I have 2 pieces. This is probably unnecessary, but I just tidy up the cut marks there, and these are about 24mm wide now. I clamp them together and drill out the holes that I need, so there's a 12mm at one end and an 8mm at the other end. Once that's done, I round those ends off just to give it some aesthetics. Now I'm doing a test assembly. These bars are screwed to the side of the spindle sheave, and then they're connected to the pivot bracket via a M12 bolt. And I'm just tacking on that pivot bracket to the back plate. And then I give that a bit of a test out, and that works perfectly. That is really nice. Now I want to give this fork bracket a bit of support, so I put a couple of plates in here. The first one I can actually put in while it's in place, and I just tack it in there. And the second one I do on the bench, and those are welded in and cleaned up. The next step is to work on the adjusting lever or dial, and I'm going to use a bit of M12 thread for that. There will be 2 pieces of steel with tapers on them, so this one will be on the M12 thread, and this one will be welded to that fork bracket. And then when I wind in or out that M12 thread, these slide a little bit like that, which push the one closest to us out, and that pushes the sheave out. Now I work on the taper adjusters. This one here takes the M12 thread, and it's the adjustable taper adjuster, and this one is the fixed taper adjuster. This is going to be drilled off center so that I have some meat to machine off for the taper. I use a center drill so I can dial it in the 4-jaw chuck. Then I drill that out for a M12 thread. This is the stationary taper adjuster. I cut that down to length, and pretty much the same thing. I just center pop a center, put it in the 4-jaw chuck, and this one is actually drilled out to 12 millimeters. Now that stationary taper adjuster fits into this bracket, so we need a 12 millimeter hole drilled in there. And it also doesn't fit too well in the fork bracket, so I have to mill a little bit off here. I'll explain a bit more about that later. Doing a test fit. I've almost finished these two parts here. As you can see, this one here I had to chamfer a little bit off the back here because of this supporting brace for the arms. Probably was a little bit low. Maybe I should have welded that a bit higher. But anyway, that's fine. This is supposed to pivot, and the reason why is because when this is getting pushed out, it will be at a different angle. So being fixed inside here will not be a good idea. So that's why that pivots. Now the next steps are to cut the tapers on this piece and on this piece so that they can sort of work together and push the arm out, and when done the other way the arm can move back in. Now I've worked out that down the bottom here, because of the distance, it's only 4 millimeters that the arm needs to come out down the bottom, which will move this top movable pulley sheave the full width of the belt. So in the position it's in now, the belt rides very low in the pulley, and then once this is pushed out 4 millimeters, it'll come right across and stop where the belt is riding way at the top here. So 4 millimeters doesn't sound like much, but you actually need quite a bit of angle on here, and I've worked out that I need 13.25 degrees angle cut on here and cut on here for this to work in about, say, 4.5 turns for the whole range of movement. That would be ideal. So 4.5 turns would give you plenty of variation throughout the whole range of the speed, but I'm not going to be able to get 13.25 degrees on here because the stock isn't wide enough. Although I've offset drilled the all thread, there's still not enough meat here, and also there's not enough meat on this piece to do that 13.25 degrees. So I'm going to have to cut that down and do around about 6 degrees, and that will use up all of this meat on here, so I don't really have much other choice apart from making bigger blocks that fit in here. So in the end, the full travel will be about 9 turns of the handle, which I don't think is going to be too bad. But let's mill these pieces out and put them in and test them out and see how that works. I didn't want to make any foul ups here, so I just scribed a line on which angle we needed for the tapers. I went back and had a good look at this and thought that I can actually use about 13 degrees here. It's not going to get right across the whole piece of steel, but it's probably going to be enough just to push that fork bracket out. So both of those taper adjusters are milled to 13 degrees, and I actually have to put the adjustable one back in and mill this part out so that it fits in behind the fork bracket. Now I'll start working on the lead screw and the handle. I take the lead screw down to 8 millimeters. This is part of the handle, and that will go over that lead screw, so this is drilled out to 8 millimeters. The next two parts are also part of the handle, so this is the flat bar, and this is the handle itself. The flat bar is drilled out so that that handle part can go through into there. And here's a trick that I learnt from an old machinist. Use your ruler and you just move the vise until the ruler is level, and that should give you a pretty good indication of where the center is. I'm drilling a hole for a M6 grub screw, and I tap that out. Now I'm going to weld on the flat bar to the handle, and also the centerpiece that goes onto the lead screw gets welded to the handle. Now I need to mill a flat in the lead screw so that the grub screw can tighten down on it. This piece here is a spacer, and also it has a hole in it for the lead screw to come through. I assemble all that up to check fit it. And put the handle on there. And then I work out where I need to put the guides. I make some guides for the movable taper adjuster. And this is just 10mm scrap steel that I found. It needs to be nice and flat, so I put it in the mill and flatten it off. And then one of those guides is welded to each side of the movable taper, and that keeps that taper running nice and straight. I have it all assembled now, and I tell you what, this is absolutely awesome. This works fantastic. You just wind the handle, slowly goes out, wind it back, comes back in. Brilliant. I don't think the video does it much justice, but with this new mechanism in here, the noise and the vibration is just dramatically reduced. Yeah, as you saw there on the video, it does work very nicely. Just wind the handle up or down, and that increases your speed or decreases your speed. So the mechanism works absolutely fine. There's a few little things in here that I need to finish off, but I'll probably do that off camera. And one of those things is putting a bearing on the end of the all thread down the other end here. So I'll probably just turn it down to around 8mm, and I'll put a small bearing or something down there. It probably really doesn't need it. These guides hold this movable taper adjuster very snugly. So, and of course there's force pushing it back against the plate from the pulley sheave at the top here. So if I grab the all thread at the back here and move it, it's not moving anywhere. But I think I'll still put a bearing or something in there anyway. Now this handle, I just quickly made this up. This probably won't be the finished handle. I might make something a little bit better. Maybe that doesn't stick out so far. Maybe it has a round piece on here that moves around, so you know you're not holding the bit that's turning. But I'll get onto that a little bit later on. And the next steps will probably be covering all this stuff in. I do want to put a cutout on this piece here for the reef counter display that will go in here. This will be taken off here, and another piece will be put on here to do the same purpose, but it'll be part of the structure of the casing that goes around the outside here. I did eventually get a spring from a scooter for down here, and this is the spring here, so you can see that it's a lot larger. It's 4mm thick instead of the 3mm here, and it's got a lot of, a big gap here, so you can put a lot of pressure in here and tension it up. So I'm going to make a piece in here where the spring can sit into, and of course a piece at the top similar to this, and then we'll look at putting all the housing and casing around these pulleys. Here I'm making the spring retainers. This is the bottom one that goes against the sheave. I don't really go into much detail here, it's just simple machining. And this is the top piece. I used trepanning here to cut the groove for the spring to fit into. We assemble that up. There's a bit of tension here, but I can hold it in quite comfortably. Then I test that out. This gives us just under 500 RPM, which is really good for a low speed. So now I start working on closing in the pulley area, and I'm welding this 6mm plate on the back end. I didn't have any more 6mm plate, but I've got this 3mm plate which I cut a piece off. This is for the front panel. To hold that front panel on and the back panel, I need to make up some sort of framing. So I'm using this 12mm square bar, and that's welded together using my 90-degree jig. That's welded onto the side panel and the panel bolted to the lathe. I'm drilling holes slightly smaller than the bolt holes I need, because I'll use these holes as guides to drill the holes that I need to tap out into the square bar. I tap that out for M6 and do the same for the other side. It's pretty much rinse and repeat. There's 3 of these braces that go round and they're all tapped out, and then I am able to screw that panel on the side there. Now I need to find the center, and I've slightly ground the lead screw to a point so that I can slide it in there and put a bit of bearing glue on there so I can easily mark it. And I drill that out to 8mm, and that fits through the hole. Now I need to work on the handle. This is the temporary handle I made, but I can actually use this piece for the new handle as well. I found a piece of this 120mm by 10mm thick tubing, and I clean up a piece about 15 to 20mm long. I did try and cut that off in the lathe, but even my slower speed was not slow enough, so I had to take it out and use the angle grinder. Then I clean it all up in the 4-jaw, and I put some chamfers on there, mainly for aesthetics. Now I cut the piece off that I need for the handle. This is a bit of bar that will join that centre piece of the handle to the outside part of the handle. There's 3 pieces that are cut off, and they're ground to fit in between the 2 parts. Now I want to space these out exactly, a 1/3 apart. So I'm using my indexing wheel here. And I describe a mark on there. That gets turned around 1/3. There's another mark, and of course the 3rd mark is put there. Then I weld those all together. Here I'm drilling a hole for a M6 screw. So this is for the handle that you'll hold to turn the wheel. Now I turn down a M8 bolt, and then I cut a M6 thread into that turn down piece. I want to make it so that the piece you hold on to actually spins, so that's what this piece is for. This is 20mm round stock, and it's just drilled out, and a larger drill at the end where the cap head screw goes into. And then again, for aesthetics, I'm just putting a taper on there. We assemble that up, tighten it down, and then that spins nicely in there. Now we assemble everything back together. Put a bit of grease on the sliders and on the thread. And the hinge bolt goes in there. I've already put the other tapered slider in there, and I'm just tightening that up now. And that all works nicely. I bolt the fork onto the sheave and then put the outer sheave in. Now the panel goes on the front, and then the handle goes on to the lead screw. Now I filmed this 3 different times, so this is not in sync, but I tried to get different angles so that you can see the mechanism working. Well, that's the mechanical speed controller complete, and it works really well. Now, if you can hear a bit of noise in the background, we're in the middle of the storm here, 14th February 2023 in Auckland, so I'll just try and speak a bit louder. As you saw there, we just wind it up and wind it down to change your speeds, and that works really well with this handle. This part is just spinning on here, so you're not holding something solid. So that worked out pretty good. And I did start adding the surround for the pulley area here. Now this piece here is a bit of 6mm plate, and that is bolted onto the lathe bed, the top part of the stand and the legs as well. And on the other side is another piece the same width, but I did sort of run out of steel, so I've used a thinner piece for this one here. And this is a removable panel, so there will be some switches, maybe a emergency stop switch, an on-off switch to go in here. And this is actually bolted onto those right angle bits of steel that I made up. So there's 3 of those that go down the side there. Now there is quite a bit more to do to this, so I'm going to stop this video here because it's getting kind of long. But I do need to cover in the top here, and I've got a bit of MDF that goes on the back here that will screw to these bars. But there are a number of other things I need to do, is put in a RPM gauge or electronic rev counter, and of course that needs to work off the spindle speed. So I will need to make another spindle that needs to be kind of a little bit longer here, and then I'll be able to mount something on it for the RPM gauge, the magnet gets mounted to it. Also, I wanted to work on a spindle locking system. So a lot of lathes have a spring-loaded knob at the top that you lift up and turn around, and it drops down and it locks that spindle up so that you can take your chuck off the far end there. So I was going to do a similar setup for that as well, and that will be another piece that gets put onto the spindle, or the new spindle once I made it, and it will be spring loaded. And there'll be a piece of steel along the top here, and it will poke through there and into the piece of, I don't know, I guess steel round stock that I'll put on the spindle, and it will have holes in it. And that will be also used for indexing as well. So I'll put, the common sets of holes, I think it's 24 holes that common wood lathes have. So I'll put that in there as well. So it sort of acts as an indexing mechanism and a spindle lock at the same time. Once I've made the longer spindle shaft, I also want to put a bearing on the end here as well, just to give it some support. And going down where the motor shaft is, I want to put a bearing on the end down there as well, so that that's all supported. Anyway, all of that stuff will be in the next video. Well, maybe the spindle will be in the video following that. So I'll finish off the covering in. I'll put maybe some switches on here, and the rev counter gauge, and then maybe we look at the spindle after that. Look, if you do like my videos, please click on the subscribe button and click on the notification bell if you want to be notified when I make new videos. And also it'd be great if you could click on the like button. Thanks for watching.